Alrighty, so let's get into this for today. Pepsi ran a promo contest for their 20-ounce bottles of soda. Some of the caps, when you twisted them off and looked underneath, said, "Please try again," while others said, "You're a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." Mrs. Bolliton's statistics class wonders if the company's claim is true. To find out, all 30 students in the class went to the store. They each bought a 20-ounce bottle of soda. 2 of the 30 students got caps that said, "You're a winner." Thoughts? Does that seem right on? Does that seem like too many winners? Does that seem like not enough winners? What would you think? Not enough. Okay, so how many winners would you expect if 1 in 6 is a winner? 5 winners. Come on, pen. Tell me why you picked 5. Yes. Okay, so what we're going to use to represent that is N and P. So N is 30, and P is 1/6. N stands for the number of participants. In this case, the number in our study was 30. And P stands for the probability. This is what we use to calculate our expected value, which is represented this way with a capital E and then an X. So we expected to get 5 winners. Is that a guarantee? No, not guaranteed. So you said that's coming in a little bit low from what was expected. Do you guys think Pepsi was lying about their 1 in 6? Do we have some evidence that it might not be 1 in 6? Do we have convincing evidence that it might not be 1 in 6? Not sure yet. So what I want to do today is perform a simulation to try to help answer the question whether or not 1 in 6 is reasonable, even though only 2 people won. Sorry, end of the period. All right, so let me pop that up a little bit higher on the screen here. We're going to assume Pepsi's telling the truth. We're going to assume that Pepsi is such a big company, what we saw just happened by bad luck. And that 2 winners out of this class of 30, while unexpected, is not unusually low. We're going to start with that assumption. Does that seem fair? We're going to give Pepsi the benefit of the doubt. We want to figure out what is the probability of getting 2 or less winners in a class of 30 purely by chance. So we want to try to run a simulation here. I need to think of a way that I could use some type of device to simulate this. If we know that 1 in 6 is a winner, at least according to Pepsi, what might be a good thing that I could use to help simulate this? A die. Absolutely. Why a die? We have 6 sides. I've got your standard 6-sided die right here. I'm going to give everybody a 6-sided die. If 1 in 6 is a winner, how many sides on the die should represent winning? 1. So let's pick out what we as a class decide means winner. What number on the die do you want to mean winner? 3 or 4. Medium and center's back down this row. Why don't we go with, I heard 6 quite a few times. Why don't we go with 6 as a winner? All right, so we're going to use a die to represent this. 6-sided die. It's important to write 6-sided because they make dice with more than just 6 sides, and they make dice with less than 6 sides. You can get a 4-sided die. So we need to write that down. Yes. You can use a random number generator. You would want your random number generator to just pick out numbers 1 to 6, and we'll still go with 6 as a winner. All right. We're going to let 6 represent you're a winner. And so 1 through 5 would represent what? Loser. What did the cap say? Does anybody remember? Looking up at the top. Yep. Let 1 through 5 represent try again. How many people were in Mrs. Bolliton's class? 30. So you're going to take your die, you're going to roll it 30 times, and you're going to record how many of those 30 rolls came up a 6. So make sure you keep track of your rolls. Make sure you keep track of how many 6s end up in those 30 rolls. You're going to record that number here, and then you're going to do it a second time. I want you to roll the dice 30 times again. Record how many 6s you get here on number 4. All right? So everybody's going to end up rolling their die 60 times total, right? 30, record the number of 6s, do 30 again, record the number of 6s. I'm going to bring around some dot stickers. Everybody's going to get 2, 1 for each of your sets of 30 rolls. Sorry, I'll shut up here in just a minute so you can count. With those 2 stickers, however many you say would have been winners on your first set of 30 rolls, you're going to come and put the sticker wherever that happens to be. And then you'll do the same thing for your second set of 30 rolls. So far, so good? All right. Now I'll stop talking so you can count. Okay, fair enough. What? Because you do a set of 30, count the number of sixes, put a dot up. Then you're going to do another set of 30. So you have one dot for each of your sets of 30. Yes, 2 trials.
Said, do we put golf on there? What?
Akeen, they should be different numbers.
Yeah.
Yeah.
I know.
Yeah, you're going to put both of them on there. Two and 6. All right. Yes. All right, so there is room in your notes to sketch the resulting dot plot. Yep, you're going to put both of them up. All right, so on mine, I put my 2 stickers up, one for each of those trials. Has everybody had a chance to put their 2 dots up? Awesome. I want you guys to sketch the dot plot into your notes. I'm going to come around and collect your die while you are getting that sketched in. Make sure you label your axes so that it makes sense when you look back at it. What were we recording? What is this a dot plot of? How many winners were there in Mrs. Bolliton's class again? 2 winners. How many trials did we have where there were 2 or less winners? 2. We're going to cut this off, and we're going to go this way. So 2 out of, let's figure out of what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So 2 out of 36. What'd you say, Keen? Double check that on the calculator, but I think you're right. You said 5.5%? So what percent of the time did Mrs. Bolliton's statistics class get 2 or fewer just by chance? 2 out of 36, 5.5%. Before we go on and answer question number 8, I have a question for you. What does each one of these dots represent? What'd you say? A trial. A trial of what? A trial of 30. So why don't we have 30 up there? It's not just the trial of 30, but that's important. So each dot is 1 trial of 30 dice rolls. And what? In this case, I'm pointing to one of the 5s. Why did they put the dot sticker at 5? That's how many winners they had in that group of 30, right? And number of 6s rolled in that trial. So each one of those dot stickers represents 30 rolls of the die and how many 6s turned up. Every single one of those. Does it seem plausible that the company is telling the truth, but that the class just got unlucky? Yes. Why? Majority of 5, which was our expected amount. All right, hold on. I started answering the wrong question. Just got unlucky. So what I'm going to say is the class most likely just got unlucky. There's a 5.5% chance of getting 2 or fewer winners in a class of 30 purely by chance. Does anybody remember what our cutoff percentage is? 5%. We're over that 5% mark. Not by much, but we are over it. We use 5% as our hard and fast dividing line. There's a 5.5% chance of getting 2 or fewer winners in a class of 30 purely by chance. So then I would say we do not have convincing evidence Pepsi is lying.
So if the percentage was like 4.9%, then you would have.
That is correct. 4.9%, and I would say we do have convincing evidence that Pepsi is lying. Does that mean Pepsi's definitely lying if I say I have convincing evidence? No. Does that mean that it's likely they are lying? Yes. So we would say that, I'm going to write up here because I ran out of room, but I'm going to put this down with number 8. I'm going to draw an arrow down there. Getting 2 or fewer winners in a class of 30 is not exceptionally rare. .5% is greater than 5%. If we say that it happens less than 5% of the time, then we're saying this is rare enough that I'm going to consider this evidence that my assumption at the beginning was false. Yes, sir.
So on the test question, do you have to word it like that?
So what I would want to see on a test question is you have to indicate whether the results that we saw were likely due to chance or not. So if we'd come in at, say, 4.4%, then we would say the results in this class of getting 2 or fewer winners is not likely to have happened just by chance. It's too rare. It's less than 5%. And then we would say we do have convincing evidence in that case that Pepsi is lying.
Okay.
So those are the pieces that you would need to make sure to talk about if this was a test question. Is this likely due to chance or not? That 5% cutoff is what we're looking at. And then you have to make a statement at the end. It is, we do have convincing evidence, or we do not have convincing evidence. Sarah, you had a question.
So like going back to the last unit, because I would be confused. So this is statistically significant.
Our result here was not statistically significant. Yes. If it had come out at 4.4%, then we would say it is statistically significant. Because now I have evidence that I could go to the company and say, I don't think you're telling the truth. I'm not going to have the guts to go to the company and say, I don't think you're telling the truth, unless I have this kind of evidence showing that it's sufficiently rare that what happened in Mrs. Balatin's class just happened by chance. Does that help? All right. Let's go ahead and flip this over. So when we do simulation, we're imitating chance behavior based on a model that accurately reflects the situation. In this case, we accurately reflected a 1 in 6 chance. So we chose an appropriate device to use for that simulation. We chose a die. Morgan asked if they could use a random number generator. That would also be a reasonable device to use here. Can anybody think of any other devices that we might have used? We haven't talked too much about many other devices, have we? What about if it was 1 in... Oh, I'm sorry, I didn't see your hand up, Lacey. What's your thought? Like a spinner? Yeah. Yeah, like a Wheel of Fortune wheel or a spinner in a game. We could have used a 6-sided one of those, absolutely. Anything where we can assign 1/6 of whatever we've got to be the it's a winner. and the remaining 5, 6 are try again. We could use as simulation devices. So dice roll, absolutely. Coin flip, I'd only want to use a coin flip when my probability is what? 50-50. Then a coin flip would work. We've used the applet before, you know, when I've had the computer do a dot plot for us. It can randomly simulate. I'll show you guys that again later. But there are apps that can basically use random number generators there. We can use a random number generator. Just about anything we have that is governed by chance, we can use to simulate our chance behavior. Simulation process, we're going to describe, if I ask you, explain how you could use a dice to simulate Pepsi saying there's a 1 in 6 chance of being a winner. You're going to start off by describing how you would simulate one trial. So in this case, that would be how many dice rolls? How many dice rolls was one trial? 30. So if I was describing what we did today, describing the simulation process, I would say take a 6-sided die, let 6 represent you're a winner, and 1 through 5 represent try again. Roll the die 30 times and record the number of 6s that occur. That's all just right here in number 1. I can kind of shortcut number 2, perform many trials, say, repeat this process many, many, many times, record the results, and in this case, we would have to compare that. So we were comparing to the results that happened in the real world in Mrs. Balatin's class. I want you guys to give that a try. Down on the check your understanding section, I want you to answer parts A and B. So describe how you would carry out a simulation to estimate the probability that on a fair wheel, bankrupt comes up 10 or more times. Oh, sorry, I didn't see part C. You're also going to answer part C.
Do we take account the little bankrupts as well? Like the small ones? Like E-Bank? We take into account these, right? Like the one that's...
So that whole thing, bankrupt on both sides, that is one
just
sliver.
one.
That is one. Good question. On that Wheel of Fortune wheel, yours printed a little bit different, but like this guy right here is one bankrupt. Needs to be the same size wedges as all the other pieces on there. So I want you guys to describe how you could carry out a simulation. Then I want you to look at the simulation that was already performed in that dot plot and explain what one of those dots means. And then tell me what conclusions you could reach based on that. Let's see what you came up with. What do we have? What do you guys say that we could use to simulate, to estimate the probability that this is a fair wheel? Should we use a die? No. What did you guys use? What kind of a device was used? I went with a random number generator as well. I said use a random number generator to create a list of 50 integers from 1 to 9. Why 1 to 9? Yeah, that's the probability that it gives us up here if the wheel is fair. There's a 1 out of 9, so I'm going to go with my integers 1 to 9. I'm going to let number 1 represent bankrupt, and I'm going to let 2 to 9 represent the other outcomes. That sentence right there is absolutely vital. It doesn't matter what order I put those sentences in, but you absolutely have to tell me which piece of the device that you chose is representing the outcome that we're looking for, and what do the other values represent. Count how many ones show up in the list of 50 integers. Are we okay with repeats this time? Yeah. I'm going to create a list of 50, and we've only got integers 1 through 9. So what should I do after I have my list of 50 integers and I've counted all the ones? No? Let's go back and look at our simulation process. What we've done right now is we described how we'll simulate one trial. So what are we going to do next? Do it many, many, many times. Just like I didn't have you guys stop with just one roll of 30 die. Everybody in the room had to do it twice. So we have more dots up here than we have people in the rooms. And each one of those dots represents the dice being rolled 30 times. The dice being rolled 30 times was a single trial. In this case, the wheel being spun 50 times is one trial. So we're going to do this many, many times. And then what? We've described how we're going to do one trial. We've explained that we're going to do a lot of trials. What will come after that? Yes. Yep. We're going to estimate the probability of getting 10 or more bankrupts in 50 spins. So we're going to make a dot plot from all of these repeated trials, which they made a dot plot for us. They did it 100 times, assuming that it really is a 1 in 9 chance of getting bankrupt. So we're going to use that to answer the question. We're going to estimate the probability of getting 10 or more bankrupts in 50 spins, because this is what was observed up here. So now we're going to see whether or not we have convincing evidence that the wheel is not fair. We started off with the assumption that it was a fair wheel, right? That it really is a 1 in 9 chance of getting bankrupt. What does a single dot up here represent? A trial of 50. What'd you say? Well, then why is it at a 12 if this is a trial of 50? I agree that it's a trial of 50, but there's more to it. How many times it landed on bankrupt, or how many times the number 1 came up. Each one of these dots is representing 50 random numbers and how many ones occurred. One simulation of 50 wheel spins. In the case of the one that I'm pointing at right there, there were 12 bankrupts, or 12 number 1s that showed up. How many in these 100 simulated trials had 10 or more bankrupts? 4 out of 4 out of 100. There's 100 little dots on here. They told me right here they did 100 simulated trials. 4 of those 100, or 4%, had 10 bankrupts or more. So is it reasonably common to get 10 or more bankrupts when you spin the wheel 50 times? Is it sufficiently rare that I believe this isn't really a fair wheel? Yes. What conclusion could we draw? Assuming that the wheel is fair, that's the assumption that we made at the beginning, there's about a 4% probability of getting 10 or more bankrupts in 50 spins. Because this is unlikely, less than 5%, we have convincing evidence of an unfair wheel. The homework that you guys picked up yesterday is due tomorrow. Does anybody need another copy of it? Some things that I'm asking you to do on the homework. I want you to interpret the probability on number 1, part A. So they tell you what the probability is. I want you to tell me what that means. We practiced doing that in yesterday's lesson, so you can go back and look at pages 3 and 4 for how to interpret probabilities. For part B, for number 2, for number 3, I want you to explain to me on those particular scenarios. Number 4, this goes with today's lesson a lot. I give you different simulation devices and a scenario. I want you to tell me how you would use each of those devices. So that would be like step 1 of the simulation process. Tell me how you would do that. On the back side, you're going to do something fairly similar to that. You're going to describe how you would set up a simulation. And you're going to analyze a dot plot where the simulation was already carried out. And tell me what conclusions you can reach. So something like part C right here. Bring that with you to class tomorrow. And we will go through that. I will give you the next homework, which is going to be due on Friday. Like I said, this is a really, really, really short chapter here.